Okay, today we're going to look at adding and subtracting fractions, but before we get there, let's take out a clean sheet of paper and let's look at finding common denominators and simplifying. So, let's say I have the fractions 3/4 and 8/10. Okay, so before I even worry about the operation, like adding and subtracting those, whatever it is, I need to find common denominators. So I need to find what we call the LCM. So hopefully you remember that from previous grade levels. That is the least common multiple. So if I think about just counting up by 4s, and then I think about counting up by 10s, then whichever number they have in common, that first number, that is my LCM, which is also my common denominator. So then I'm going to multiply the denominator by a number to get 20, or in this case, to get the LCM. So 3/4. Okay, so I'm going to think, okay, what number times 4 would give me 20? And so that would be times 5. So give me 20 on the bottom, 15 on top. And then I would look at 8/10. Well, if I multiply 10 by 2, that would give me 20 on the bottom. Do the same to the top. And so I'd get 16/20. And then from there, I can worry about the operation, if it's adding or subtracting, and I'll get my answer. Okay. Now, if for some reason it's very hard for me to figure out the LCM, I can take the two denominators, like 4 and 10, and just multiply those two together. And that would give me 40. And 40 would be a common denominator. If I kept counting by 4s and by 10, I would hit 40. Now, that's not always going to be the least common multiple between your two fractions, but at least it will give you a common multiple. It just means that you may have to reduce more at the end of the problem. So let's look at another example. So 9/12 and 2/18. So again, I'm going to look for the LCM. So I'm going to count by 12s. And I found it. It'd be 36. Okay, so then I'm going to think, okay, what number times 12 would give me 36? And that would be times 3. So it'd be 27/36. And then, okay, 18 times what would give me 36? Well, 18 times 2. Do that to the top 2, and I'd get 4/36. And so then I have common denominators. Again, if I couldn't figure that out, I couldn't find that it was 36, I could just take 12, multiply it by 18, and I would get 216. So this shows you a perfect example of when multiplying by the bottom, yes, it's going to give me a common denominator, but is it necessarily going to be the easiest one to deal with? Is it my least common multiple? No. So what this is going to do is it's going to make me reduce even more at the end after I have added or subtracted for this problem. So let's look at reducing. Okay, so with reducing, what I'm looking at is now I'm going the opposite way. So I was finding least common multiple for a common denominator. Now I'm going to go backwards and I'm going to find the greatest common factor. So there's a couple of different methods. There are some shortcuts. So one of the ones that I always look for is if they're both even numbers, both top and bottom are even, then I know I can always reduce by 2. If the number is very large, then I may have to do that multiple times, or there may be other numbers to reduce by. If the last digit of both the top and bottom is a 0, then I could reduce it by 10. So in this case, I can reduce this one by 10, because top and bottom, the last digit is a 0, and this would give me 3 over 5. And then there's only a factor of 3 and 1 and 5 and 1, so that is done. I have nothing else to reduce it to. Depending on how you learned factoring, you may have learned it by a factor tree, or you may have learned prime factorization using this method that some people call the upside down wedding cake. And either of these ways would actually work too in order to get this answer. If I think of a prime number that would go into 30 and 50, let's say 2. So 2 goes into 30 15 times, 2 goes into 50 25 times. And then I kept going. Well, 2 doesn't go into that. 3 would not go into both. Next prime number would be 5. 5 would go into 15 3 times. 5 would go into 25 5 times. And then I can't go any further. This would be my answer, 3/5, which is what we found up here with this method. With the factor tree, it would look similar. I would just break this into factors. So 30 would be 3 and 10, which would be 2 and 5. 50, let's say you do 5 and 10, and then that would break into 2 and 5. And then I would cross out the ones that they have in common. And so I'd have 3/5, which is what I got up here. And then another way just to represent that factoring, I can just think in my head, okay, what two numbers multiply together to get 30? So let's start with 3 times 10. Then with this method, I would have to use one of the numbers in the numerator, either 3 or 10. And I can do 5 times 10. And then the reason I had to have the same number, didn't matter which one, just the one that would work mathematically, is because this reduces. I needed something to reduce. So 10 over 10 is just going to be 1. And so I'm left with 3 over 5. And then that can't break down anymore, so that is my answer. Let's look at another one. So I got 24 over 80. So I can just start with a common factor that I know off the top of my head. So let's say I see that they're both even, so I'm just going to start with 2. So I'm going to divide both by 2, and I get 12 over 40. And then let's say, maybe I see that they both have a factor of 4. Divide by 4 and get 3 over 10. And then that can't go any further. Okay, the second method, the upside down wedding cake. So again, that's just the method. But if I were like talking on the milestones, like writing out what I'm doing, I would be doing prime factorization. So 2 goes into 24 12 times. 2 goes into 80 40 times. And then I can keep going with the 2. 2 goes into 12 6 times. 2 goes into 40 20 times. And then 2 goes into 6 3 times. And 2 goes into 20 10 times. So I get 3/10. Or the other method, the last method, 24 over 80. So I'm just going to think, okay, what do I know that, what are 2 factors of 24? So I know 6 times 4 would be 24. Now, using one of those numbers in the numerator, what 2 factors can I think of that would make 80? So I know 40 times 20. Well, 4 over 4 is going to reduce to 1. So I'm left with 6 over 20. And then I'm going to think, okay, what 2 factors make 6? So 3 times 2. Again, using one of those numbers in the top, what can I think of that would make 20? Well, 2 times 10. 2 over 2 is going to reduce to 1, and so I'm left with 3 over 10. So you can pick one of those methods to reduce. If you have another way, that is totally fine. As long as it's correct, you get the same answer I do, that is totally fine. You pick that and you go with it. Let's look at what this would look like on a calculator as far as reducing and entering in fractions. So your fraction button is in the second column, third row. It's the N over D button. So if, let's say, I want to reduce 80, so I type in 80, hit the fraction button, and then let's say 135. When I hit enter, it is going to reduce it for me, so it's 16 over 27. Let's say I want to do 1,000 over 12,340. Hit enter, and it reduces. If I want to do a mixed number, it's actually that same button, but what I would need to do first is hit the second and then the fraction button. Notice I have the 3 boxes there. So the first box is going to be for my whole number. Then I use the arrow buttons over here. Let's say I want the fraction to be 90 over 145. Hit enter. Now it might switch it to improper like mine did. So then I'm going to hit second times 10 to the nth power, which is right beside the fraction button, and then hit enter. And notice it reduced it for me. Once it switched it back to a mixed number, it went ahead and reduced it. Let's look at the printed note sheet, starting with the side that says adding signed fractions. So step 1, find the least common multiple. of denominators if necessary. Write both fractions to the least common multiple, add the numerators, keep the denominator, and look carefully at the signs, and then you'll write the sum in simplest form. So looking at example 1, we have 3/5 plus 1/3. So this is your problem right here. This over here is just the work that they did to get to the answer. So we have 3/5 plus 1/3. So they found a common denominator of 15. So that meant that they multiplied the first fraction by 3 to get the 9/15. And then they multiplied the second fraction by 5/5 to get 5/15. Then they take the numerators and add them together. So 9 plus 5 is 14, and then the denominator is 15. Since these digits are 1 away from each other, it cannot reduce. So that is my answer, 4/15. So let's look at example 2. The rest of the examples, 2 through 4, are going to have that same fractions that we started with, 3/5 and 1/3. They're just going to change where the negative is. So we have 3/5 plus negative 1/3. So again, common denominator is still 15. So we have 9/15 plus negative 5/15. You can see right here, we're going to have to pay attention to the signs. So those have different signs. So we're going to subtract and take the sign of the one that's furthest from 0. So that positive 9 is further away from 0 than negative 5 is. So that means that this is a positive 4/15. That does not reduce, so my answer is 4/15. Number 3, this time the first fraction is negative, so negative 3/5 plus 1/3. Again, common denominator is 15. Once I have that common denominator, then I'm going to put the numerators together. So I have negative 9 plus 5. Negative 9 plus 5, well, they have opposite signs, so I'm going to subtract and get 4. And then I'm going to look and see which one's further from 0. So the negative 9 is further away. So that's the sign I'm going to take. So my answer is negative 4/15. Example number 4, both of these are negative. Common denominator is 15. I'm going to add negative 9 plus negative 5. Since those have the same signs, they will just be added together, and I keep the sign. So I have negative 14/15. That does not reduce, so that is my answer. Okay, next page you see that they take more and more away from the problem, so we're going to have to fill in a lot more. For the first one, they did find common denominators for us, so we have 5/8 plus 1/3. Well, if I multiply the first one by 3, top and bottom, and then multiply the second one by 8, that would give me 24 as the denominator. So this would be 15/24 and 8/24. 15 plus 8 is 23 over 24. That does not reduce, so that is my answer. Number 2, I have 3/7 plus negative 1/5. So common denominator is 35. So I would multiply the bottom and the top by 5. So this is 15 over 35. Multiply the second fraction by 7. So this is negative 7 over 35. So put the numerators together, 15 plus negative 7. Since those have opposite signs, I'm going to subtract and take the sign of the higher absolute value. So I'm going to have positive 8 over 35, and that does not reduce. Number 3, I have negative 4/9 plus 1/2. Those do not have common denominators yet, so I'm going to have to figure that out. So again, back to the first part of the video, if I'm looking for common denominators of 2 and 9, I can sit here and I can count up by 2s and count by 9s. And I will eventually get to 18. 18 will be the common denominator. So I'm going to multiply top and bottom by 2, and I'm going to get negative 8 over 18. Multiply the second fraction by 9 and get 9 over 18. So negative 8 plus 9, those have opposite signs, so I'm going to subtract, take the sign of the higher absolute value, and that will be over 18. So my answer is 1 over 18. Number 4, I have negative 11 over 15 plus negative 2/5. So common denominator between 15 and 5 would be 15. So since that first fraction already has my common denominator, I can just leave it. I don't have to do anything to it. The second one, I would need to multiply by 3, top and bottom, to get negative 6 over 15. I'm going to add the numerators together. So negative 11 plus negative 6 would be negative 17 over 15. And then I already showed you on the calculator, if it's an improper fraction, you would hit the second and then times 10 to the nth power button. That's right beside the fraction, and it's going to convert it. If I need to do this by hand, I would just think, okay, how many times does 15 go into 17? And it would go in there one time with 2/15 left over. So 1 and 2/15. And then I would keep the negative in front. So my answer is negative 17 over 15 or negative 1 and 2/15. Number 5, I have 2/3 plus negative 11 over 12. So 12 would be my least common denominator here, my least common multiple, so I'm going to leave the 12. I am going to multiply 3 by 4, so I get 8 over 12. So then I'm going to add the numerators together. 8 plus negative 11 would be negative 3 over 12. That does reduce. 3 is a common factor between them, so divide this by 3. And my final answer would be negative 1 over 4. Number 6, I have negative 9 over 16 plus 5/8. 16 is my common denominator, so I'm going to leave the first fraction alone. The second fraction, I am going to have to get that to 16 on the bottom, so times 2, and so I get 10 over 16. Then I'm going to add the numerators together. Negative 9 plus 10 is 1, and then over 16, that is my answer. Anytime I have 1 on top of a fraction, it's already reduced all the way down. There's nothing else to do. Okay, let's look at the back of your notes for subtracting signed fractions. So step 1, we're going to find the least common multiple again. You're going to write both of the fractions with the least common multiple as the denominator. You will subtract, keeping the numerator the same. Look carefully to determine the signs. Remember that when you are subtracting with negatives, use the additive inverse or add the opposite, and then write the difference in simplest form. Okay, so let's look at the first one. So we have 3/4 minus 1/3. So you can see that they found the common denominator of 12. And so they put the numerators together. 9 minus 4 is 5 over 12. Those do not have a common factor, so they can't reduce. So that answer is 5 over 12. Number 2, same numbers, but this time that 1/3 is negative. So still have a common denominator of 12. You have 9 over 12 minus negative 4 over 12. So remember, subtraction of a negative, this is going to be addition. Change this to the opposite sign. So we're dealing with 9 plus 4. So 9 plus 4 is 13 over 12. That is an improper fraction, so we do need to convert that to a mixed number. So you're going to think, okay, 12 goes in the 13 one time with 1 left over. So start at the top and go clockwise. 1 and 1/12 is your answer. Number 3, you have negative 3/4 minus 1/3. Common denominator is still 12, so I have negative 9/12 minus 4/12. So I'm going to put the numerators together. Well, negative 9 minus 4, that is the same thing as negative 9 plus negative 4, which would be negative 13 over 12. Well, we just saw above that 13 over 12 was 1 1/12. So that means that negative 13 over 12 would be negative 1 1/12. Example number 4, again, common denominator is 12. This time we have a negative minus a negative. So this is going to become addition, and then this will be the opposite sign. So we're going to have negative 9 plus 4 on top over 12. Negative 9 plus 4. Well, those have different signs, so I'm going to subtract. Take the sign of the higher absolute value. So negative 9 is further away from 0 than 4 is. So that's the sign I'm going to take and put that over 12. That does not reduce, so negative 5/12 is my answer. Okay, let's look at number 1. So we have 5/8 minus 2/3. So they already found the common denominator of 24. So I know that 3 times 8 is 24. So I'm going to multiply the top and bottom by 3. That gives me that this is 15 over 24. And then 2/3, well, I'd multiply that by 8. So this is going to be negative 16 over 24. So they went ahead and they already used the additive inverse, so they rewrote it for you. So it was subtraction, and now they changed it to addition, changed the sign of the second fraction. And then I just followed my integer rules. So I have opposite signs, so I'm going to subtract. 16 and 15 would be 1. And then it's going to be negative because negative 16 is further away from 0 than 15. Number 2, my common denominator is 35. I multiply the first one by 5. So this will be 15 over 35. Second fraction, I would multiply by 7. So this would be 14 over 35. Again, they've already used the additive inverse, so they have changed the subtraction of a negative to addition, and then this would be a positive. So I got 15 plus 14 as the numerator, which would be 29 over 35. Number 3, I need to find out the common denominator, but it's not that hard. We have 9 and 2, so that means the common denominator would be 18. And again, I would get that by counting by 2s and then by 9s and seeing when they would be at the same number. Or I can just multiply the two denominators together. And in this case, that does give me the least common multiple, the least common denominator. Okay, so for the first one, since that is 18, I would multiply it by 2. So I'd get negative 8 over 18. And then the second fraction would be times 9. And so that would be negative 9 over 18. Again, they have already done the additive inverse for us. So in the numerator, I'm going to have negative 8 plus negative 9 over 18. So those have the same sign, so I'm going to add them together, keep the sign, and then that would be over 18. Okay, number 4, I need to find the common denominators. So I have 15 and 5. So I could multiply 15 times 5. That's actually going to give me a number bigger than what my least common multiple is. If I count by 5s, when will I ever hit 15? Well, I would. So if I multiplied this by 3, that would give me 15. So this will be negative 11 over 15 plus 9 over 15. Again, they've already used the additive inverse, so this is addition of a positive 9 15ths. So in my numerator, I will have negative 11 plus 9 over 15. Negative 11 plus 9, those have opposite signs, so I'm going to subtract and take the sign of the higher absolute value. So 11 minus 9 is 2, and it's going to be negative, and then over 15. And that is my answer. That does not reduce. Number 5, I have 1/3 minus negative 7/12. So the least common multiple would be 12. So I multiply the first fraction by 4, top and bottom, to give me 4 over 12 plus 7 over 12. Again, they have done the additive inverse for me. So for plus 7 in the numerator would give me 11 over 12. Again, those numbers are 1 digit away, so they can't reduce. So 11/12 is my answer. Number 6, 16 and 8. So my common denominator would be 16, so I don't do anything to the first fraction. Second one, I would multiply by 2 to get to 16 on the bottom. Rewrite it with the additive inverse, so this is now addition of a negative 6 over 16. So negative 9 plus negative 6, those have the same sign, so I'm going to add them together, keep the sign, and then be over 16. So negative 15 over 16 is my answer.